Now we've got to use the zero product property to find all complex solutions of the equation. When you are faced with a polynomial such as this, sometimes they're a lot longer, and it is in your best interest to graph them to try to see where they appear. On the number line right there, right on the x-axis, you'll find your roots by doing second trace using a TI-84, 83 plus calculator. But for this one, sometimes you can just factor it. And this is one that is quadratic in form. So you could approach this two different ways. You can just straight factor it and say, what multiplies to give me negative 18 and adds to give me a 7? The first thing that comes to mind is a 9 and a 2. And since it's a positive 7, it would be a positive 9 and a negative 2. And then right out in the front would be this middle term here, x squared and x squared. And then you set them equal to 0 and find out what they are. So x squared plus 9 equals 0 would be x squared equals negative 9. And x squared minus 2 equals 0 would be x squared is equal to 2. And of course, we use the square root property at this point to find the solutions. And what we would come up with would be x is equal to plus or minus, always plus or minus when you apply a radical, 3i. And x also equals plus or minus the square root of 2. Now, for me, I've noticed that folks are a bit uncomfortable when they see something like x to the 4th, and it's like, what? Oh my God, x to the 4th, I gotta do it 4 times? No, I encourage you to just say, let u equal the middle term, the variable, x squared. And that way, if u equals x squared, then u squared is going to equal x to the 4th. And then we can replace and rewrite this as u squared plus 7u minus 18. And for some reason, this causes a world of comfort, and folks can factor this a lot easier than when it's a 4. If you find yourself in that world, then, apply, the pressure and just write down u plus 9 equals u plus times u minus 2 equals 0, and set each one of these equal to 0 and get that u equals negative 9 and u equals 2. But then remember that we're not looking for u. We're looking for x. And remember that u represents x squared that you let it equal. So you just go back and do all the things at this point right here and end up with the final answers of plus or minus 3i, which you can write separately. You don't have to use that symbol. Or plus or minus the square root of 2. And that's all she wrote. And that's she being me. All right, move on to 22. Solve the equation for all complex solutions. Give exact values. Oh my goodness, this is the one that I was alluding to. You see how long this thing is? Now, we will be given several parts to this question. You know what the first part would be? List all the potential rational roots. But they didn't ask us that. They just said find all the solutions. So, since they didn't ask us, I'm not going to do nothing extra. I'm going to go right over here to y equals. And I'm going to type this bad boy into this calculator and see what I can see. 3x to the 4th minus 20x to the 3rd. I know what you're thinking. I should have already had these typed in there. I sure should have. But, we can type it together. We're a family. 44x squared minus 80x. Plus, I believe that was 128. Yep. Now, I don't know what this graph is going to appear like. I don't know what my zeros are going to appear like. They could be big, they could be small. I'm just going to start out with the typical 10 by 10 window and see what I can see. It's looking like I can see at least 2 roots here, and I might need to expand it out, but what I can see here is 1, 2, 3, and what looks like a 4. You see that 4 right there? And then this one, let's go ahead and find out what it is. Second trace 0. So I can get on the left side of this, which means over here around like 2. So that's already at negative 0.15. So I need to move over to the right. So always look at your numbers down here to see where your cursor is. I call it my little Teenage Mutant Ninja Turtle because it looks like a little turtle. So it's 2.57. That's on this side of the point. Maybe I can go a little further up. Enter. And then I'm going to go on the right side. Do it again. Enter. And as you can see, I'm right in between the line. And then I'm going to go back a little bit to where I think it might be. It won't get right on there. That's a problem for some folks. But I'll just press enter, because then the calculator will jump to there and we'll find out that it's 2.666666 repeating, or 2 2/3. And that's really helpful. So we know our zeros are at 4 and 2.66666, or 2 2/3, which is the same thing as 8/3. Now, if you don't believe me that that's what that is, I'm going to go second trace, and I'm going to go value, and I'm going to type in 8 divided by 3, and it's going to give me that 0. And I can go second trace, the same value again, and type in a 4 and make sure I also get a 0 for that one, and I do. Lots of things you can do with your technology. Please do so. And I'm looking over at my door like I think someone's coming in. All right, so these are 2 of my, complex solutions. How many do I have? At most, or at least, I might have 2. I might have 3. But at the most, I'm going to have 4, because that's my highest exponent. That represents the degree of my solution. So let's use our roots and synthetic division to get to the bottom of this, what the other roots might be. I'm going to show you that you can use this 8/3 to synthetically divide this function. So I've got my 8/3. It looks kind of pitiful, but trust me, he's okay. I'm going to put 8/3 and I'm going to put my coefficients. 3, -20, 44, -80, and 128. Bring down my 3. 3 times 8/3 is an 8. Going to give me a -12. Now, God being God, every single one of these numbers down below this line is going to be a multiple of 3. Watch. All right, so 8 goes into 12, -4 times. -4 times 8 is -32. It's going to give me another 12. It's going to give me a 32. And then when I subtract this, that's 10, so that's an 8. And that's a 48. 3 goes into 48 16 times, and it's a -16. -16 times 8 is -128. Somebody doesn't believe me, so let me show them. -16 times 8 is -128. See? All right, now, once I have these numbers down here, and I divided all these numbers by a fractional root. Now, we haven't focused on a whole lot of fractional roots here, and a lot of folks are saying when you do synthetic division, your book says it as well, that it must be an integer, but you can do synthetic division with imaginary numbers. I showed you that, and you can do them with fractions. However, when you're doing them with fractions, when you get this answer, you need to divide by the denominator. So we need to divide all these numbers through by 3. It's a little thing, but a big thing. All right, so if we divide it by 3, we get 1, -4, +4, and -16. Alrighty then, now that we've got those, let's use our other root. Now, will our answers be wrong if we just go ahead and do the 4 in the synthetic division? They will not. But I just want your numbers to be smaller so that we can get down with some easy factoring. So let's go down to 1. 1 times 4 is 4. We get a 0. We get a 0, we bring down a 4, and we get a 16, and then we get a 0. All right, so we started out with x to the 4th. This became x to the 3rd, which I divided by 3, and it's still x to the 3rd here. So these numbers right here represent x squared plus 4. So what are the other solutions? If you get x squared plus 4 equals 0, and you move the 4 over and it becomes x squared equals -4, and you take the square root of both sides, you end up with your other two solutions, which happen to be complex, non-real, plus or minus 2i, just pure imaginary numbers, plus or minus 2i. So let's talk about the exact solutions to this problem. They are, in bright green, 4, 8 over 3, and plus or minus 2i. How did we find them? Very unconventionally. We could have started this problem off with the 4 and then tried to do some more roots with the cubic that we created. But it is best to use your technology. Use your calculator. That's what it's for. And you only have 2 hours to do your final, so why waste time?